And simplifying ratios. So we'll remember that a ratio is a comparison of two or more amounts of the same sort of thing, so the same unit or counting objects. For example, a sample of mixed nuts contains 2 macadamias, 5 cashews and 12 peanuts. Write the ratio of cashews to peanuts to macadamias. If we are writing a ratio, we label what the things are: cashews to peanuts to macadamias. The order matters, so they said cashews to peanuts to macadamias. We can't go changing the order of that. And we write the number. There were cashews to peanuts to macadamias. Got to be careful here. Cashews, 5, peanuts, 12, macadamias, 2. So we've written those. Write the ratio of cashews to the total number of nuts. We label our ratio, cashews to total. There's 5 cashews, and the total number of nuts is 2 plus 12 plus 5, 19. Write the ratio of peanuts to other nuts, peanuts to other. Now, this isn't peanuts to total because the other nuts are just the cashews and the macadamias. So there's 12 peanuts to 7 other types of nuts. Now, the idea with a ratio is that then we could assume that this might work for a larger sample, so that there would always be 6 times as many peanuts as macadamias, or that sort of relationship. Remember, when you're writing a ratio, if they've given you the ratio with units, you would have to make sure they were the same units. We might squeeze in one example about that. Very quickly, ratios are very much like fractions. We can have equivalent fractions and we can have equivalent ratios. You don't need to write this, but remember, by getting an equivalent ratio, 1 over 2 is how much over 8. We'd say, what did I do to the 2 to get 8? I multiplied by 4, so I multiply this by 4, I'll get 4 over 8. They're equivalent fractions. Ratios are the same. What did I do to 9 to get 36? If you can't tell, you divide it back or you use a multiplications grid. 9 times 4 is 36, so 4 has to get times by 4, and I've got 16. 30 over 15, sorry, 30 to 15, it's a ratio. 15 has come down to 5. What did they do to 15 to get it to 5? They divided by 3, so we'll divide this by 3, and I'll get 30 divided by 3 is 10 to 5. So the two ratios mean the same thing. Now, if you're very clever, you can see we could still simplify this more, because ratios can be simplified exactly the same way you'd simplify fractions. Remember, if we had a fraction, don't bother writing it, 7 over 21, you'd simplify by looking for the highest common factor, which is 7, dividing by 7 on the top. 7 divided by 7 equals 1, 21 divided by 7 equals 3. So we simplify ratios in exactly the same way. Find the highest common factor, 7, divide both sides by 7. 7 divided by 7 is 1, 21 divided by 7 is 3. We get a ratio of 1 to 3. Now, the fractions and the ratios aren't exactly the same, but they do work the same way when you're simplifying or finding equivalent ones. You can also have ratios like we saw before, where there's 3 numbers, and you've got to find the highest common factor of all 3. 2 goes into all of these. 2 divided by 2 is 1. 4 divided by 2 is 2. 6 divided by 2 is 3. And what this ratio says is whatever this thing is, you'll always have twice as many of this and 3 times as many of this. Now, very quickly, just writing ratios with units. Write 1 centimetre to 15 millimetres as a ratio. If they give us units, they must be the same. So you'd convert one of these, which we learned how to do. that's 1.5 centimetres. Then keep the order, that's 1 centimetre to 1.5 centimetres, and the trick with ratios is once you've written them with the same unit, you get rid of the unit, and this is 1 to 1.5. Because a ratio works for any unit. This is saying if this is 1 metre, this would be 1.5 metres. If this was 1 kilometre, this would be 1.5 kilometres. So if you're simplifying with units, make sure the units are the same, then write the ratio and get rid of the units.